Okay, everybody, hopefully that you uploaded the Chapter 2 assignment sheet and the Chapter 2 Day 1 materials in Schoology. Sorry I can't be there today. My grandfather passed away on Saturday, and today is the funeral and all the arrangements for that stuff, so I'll be back tomorrow. But because of the internet, geometry doesn't stop. So you have the assignment guide. All the dates are on there. You see that we'll have a quiz later this week. Looks like Thursday, and all the assignments are on the right hand side for you to start creating a new homework document. I'll get those tests back to you tomorrow. But remember, if you want to check your grade, I posted those on Friday for you to see how you did. So this chapter gets really big into proofs, beginning and talking about perpendicular angles, complementary and supplementary angles. We get into proofs that involve complementary and supplementary angles. We get into addition, subtraction, and also in here is multiplication and division that deals with midpoints and bisectors and proofs. And then some important topics down towards the bottom called transitive and substitution, and vertical angles get introduced finally in this chapter 2. So it's a 14-day chapter. It's roughly about the same length as the first 2 units we did. So it's the first major chapter. We're not splitting chapter 2 in half like we did chapter 1. So there's a lot of material, a lot of learning to do. So let's get going on the warm-up. So we have a rectangle placed in a coordinate grid. And we know the 3 coordinates of the vertices of the rectangle. And the question here is that we need to find the area of this rectangle and then find the coordinates of D. So first, to get the area of a rectangle, you should know the formula for that. So the area of a rectangle is equal to what? You're correct, length times width. So we have to determine how long the sides are. So looking in the diagram here, I have point A to B, where -4 is the x value and 10 is the x value on B. So what is the distance on a coordinate grid from -4 to 10? So you can subtract the points just like lengths of segments and you get 14. And then I could look at point B and C and look at the y values because it's a vertical distance. And the distance between 8 and -2 is 10. So since the formula is length times width, my area is going to be equal to 14 times 10, which is 140. So the next part is finding the coordinates of D. So because this is a rectangle, every vertice forms a right angle. And if there's a right angle at every vertice, then our segments in the coordinate grid are vertical and horizontal. So our coordinate for D is going to have the same vertical point, so x value, as point A. So that's going to be -4. And it's going to have the same vertical value as point C, which is -2. Which makes sense because you're in quadrant 3, and in quadrant 3 all points are negative. So the coordinate of D is equal to -4, -2. So the question here, could the problem be done if the coordinates of B were not given? Why or why not? Well, if we didn't know B, so say B was out, could we have gotten it the information with A and C only? And I don't think we could, because we just look at the horizontal distance, and from A to C horizontally you have to travel 14 units, and then from A to C vertically you have to travel down 10 units to get to that horizontal line. So you do not necessarily need to know B. Okay, you could get the rectangle. If you know 2 points of a rectangle on a coordinate grid, or 2 points of a square on a coordinate grid, you can get the other 2 points very easily, knowing what horizontal and vertical lines give you in terms of their coordinates. Okay. Alright, so the first section of this long, important chapter is called perpendicularity. So, definition of perpendicularity are two lines that intersect and form a right angle. Okay? And what can we do in a diagram? Of course, we never do what? We never assume right angles in a diagram. So in terms of perpendicularity, we need to be given some information in order to decide whether two lines are perpendicular, or to decide whether we have a right angle, and then that could lead to there being perpendicular lines. So first, we have some notation that we use for perpendicular. So the notation for perpendicular lines is an upside down T. That means perpendicular. You don't have to ever spell that long word. Just use that symbol. So in the first example on the left, you got a right angle ABC. So if we know this is a right angle, we could then state that AB is perpendicular to BC. So we have a ray BA is perpendicular to a ray BC. Okay. If these two lines in example 2 intersect and form a right angle, then we have line M perpendicular to line N. On the third problem on the right, those definitely do not look perpendicular. They do not look like there is even a chance for there to be a right angle there. So we can use the notation for not perpendicular by saying that line PR and ray QS are not perpendicular. So I have the perpendicular symbol and then a line going through it. That would be not perpendicular. Okay. So some of the things that could be used in reasons for proofs. Okay, if we have perpendicular, then we have a right angle. Or we could use something like, if we have a right angle, then we have perpendicular lines. So perpendicularity can be assumed from backwards and forwards in terms of the converse. Okay. All right. So some problems here. Given that measure of angle MNO is 10 less than 4 times the measure of ONP. We're also given that NM is perpendicular to NP. So perpendicularity is going to imply that there is a 90-degree angle. So MN being perpendicular to NP puts a right angle right here. So now we know that these two angles in the picture, which are clearly different, are going to add up to 90 degrees. So one thing we know is that measure of MNO is 10 less than 4 times the measure of ONP. So we're given a lot of information here about MNO and nothing about ONP. So ONP I'm going to call X. and I'm going to write x in the angle, not move it around. And then MNO is 10 less than 4 times the measure of that. So 10 less than anything, you need to subtract 10 after the fact. So 4 times that angle minus 10. So now the perpendicularity again implied that there's a right angle. So my equation is going to take angle MNO, which is 4x minus 10, add angle ONP, which is x, and set it equal to 90. So I'm going to go ahead and solve this. I got like terms, so 5x minus 10 is 90. Add 10 to both sides, and 5x is equal to 100. So then x is equal to 20. Now in the problem it wants me to find the measure of ONP. Well, ONP is over here, which is equal to x, so I just solved that. So the measure of angle ONP is equal to 20 degrees. Yeah. Now, if I wanted to find MNO, I don't have to take 20 and substitute it in for x in that angle because I already know that this is a 90-degree angle, so the other angle has to be 70 degrees. But not asked to find it, so let's imagine I never said that. Okay, so now some proofs. This chapter is very proof heavy. You're excited. So number 2, given that the measure of angle 1 is 90 degrees, and A is perpendicular to B, we want to prove that 1 is congruent to 2. Okay? Now, remember, a 90-degree angle is not congruent to a right angle. A 90-degree angle is congruent to a 90-degree angle, and a right angle is congruent to a right angle. So that's why it says this proves more than 3 steps. So 1, we need the givens down. So we have our statements and we have our reasons. So 1, we got the measure of angle 1 is equal to 90 degrees. And 2, A is perpendicular to B. And both of these, of course, are given. So perpendicular will lead you to knowing that there's a right angle, and a 90-degree angle leads you to know that there's a right angle. So we're going to say that if angles are right angles, then they are congruent and then they are congruent in the end. So let's go from the given. Step 3, angle 1 is a right angle. And the reason is that if you have a 90-degree angle, then you have a right angle. Now step 4, we're going to use the perpendicular given. So if A is perpendicular to B, then we know that angle 2 is a right angle. So the reason on 4 is if we have perpendicular, then we have a right angle. And then finally, step 5, since we have 2 right angles, we got angle 1 congruent to angle 2. Because if angles are right angles, then they are congruent. So each given led us to 2 additional steps, which led us to be able to conclude why 1 is congruent to 2. Now if we look forward to section 2.8, this is a 1-step proof. But we're not there yet. We need to get through 7 sections and earn our way to 1-step proofs and learn more and more and more. So it's number 3. We did in the warm-up, so we're not going to do again. So you could cross this off. We did this problem about 14 minutes and 54 seconds ago. All right, number 4. You got measure of angle BFC is 2x. I'm going to throw 2x in there. CFD is 3y. Ooh, x's and y's. You know what's coming now. And BF is perpendicular to DF. So we're going to have a right angle right there. BFA is equal to y. And DFE is equal to 4x. So what we want to do here is find the measure of DFE. Now in order to find the measure of DFE, we need to, of course, solve for x and y. So perpendicular means we got a right angle. So one thing I can do is I could say that 2x plus 3y is equal to 90. Now another thing that you can assume from a diagram, of course, is a straight angle. So AFE is a straight angle. So there's a couple different ways we can go about this. Knowing that AFE is 180 degrees, if you take away that right angle, you know the rest of it is going to be 90 degrees too. So y and 4x would add the 90. The other way to do it is to add all 4 angles and set it equal to 180 because, again, AFE is a straight angle. So I'm going to stick with the smaller numbers, I think. And knowing that, 90 has already been taken care of, the y plus the 4x, so I'll just do 4x plus y is also equal to 90. So I have a system of equations. And it looks like I could use elimination or substitution. So let's do some substitution. So I know I have y equals 90 minus 4x. So this 90 minus 4x is going to go in for y up here. So now my equation is 2x plus 3 multiplied by 90 minus 4x. Is equal to 90. So that's 2x plus 270 minus 12x is equal to 90. So 2x minus 12x, that's a negative 10x, and I'm also going to subtract 270 to the other side. And 90 minus 270 is negative 180. So then x is equal to positive 18. So if I go back up to my problem, I want to find the measure of DFE, which is 4 times x. So I do not need to find y. So I have the measure of angle DFE is going to be 4 times x, which is 4 times 18, which is equal to 72 degrees. Okay. So then going back up to the diagram, if I know that this angle here is 72 degrees, I can go back and know that y has to be 18 degrees because those two have to add up to 90. And then the other part is, okay, I know x is 18, so this is going to be 36 degrees up here, 2 times 18. And then the angle that adds up to 90 for 36 is 54 degrees. So that's if I was asked for everything, but I wasn't. I'm just doing extra math, which never hurt anyone. Okay, so that's enough for right now. For notes, I think you could try these problems on worksheet 1. The substitute has an answer key, so I want him or her to put that up on the front board so people can come up and check their answers. So try these problems on worksheet 1 for the rest of the class here. I think probably got about 20-25 minutes left to go. And then try your homework tonight. And come in with any questions you have about perpendicularity tomorrow, because we are moving on. Okay. Thanks for listening, everybody.